Okay, I was only going to do 2 videos, but the last video got hijacked by a really long announcement, so I stopped it and trimmed it. So I apologize, but this is video 3 of the lesson. This one will go pretty quick. So we just have 2 more things to talk about. The first one is the complement of an event and how we use the complement to help us calculate probabilities. And what are the odds? So we'll talk about odds. So first of all, the complement, I was kind of finishing off on the last video talking about how these 2 are actually what we would call complements. So again, the probability that the students don't have a curfew compared to those that do have a curfew, right? All students either had one or they didn't, so they were all included. 8 of them didn't have a curfew, which meant the rest of them, the 25, did have a curfew out of the total 33. So when we find the complement, what that means is that the sum of the probabilities would be 1, or in other words, 100%. So the complement of A, or the complement of it not occurring, is just kind of the opposite of it occurring. And we can just subtract the probability of an event occurring from 1 or from 100% to figure out what the probability of it not occurring would be. So for example, up here on this one, the probability they don't have a curfew, right, was 0.242. So the probability they do have a curfew would be 1 minus the 2.4, oh, that's weird, 0.242. And notice when you subtract that, you get 0.758. Or in other words, if your brain thinks better in percentages, 24.2% of the time, students are going to not have curfews, which means that if we take 100% and minus that 24.2, we're saying that 75.8% of the time those students will have a curfew. Okay, so probabilities that add to 100%. Now we use the complement to help us calculate probabilities in some cases because it's easier to find the complement of the probability. So for example, on number 4, it says you roll 2 6-sided dice. Find the probability the sum on the dice will not be 6. So again, first of all, we think about, okay, well, we want to find the probability that the sum is not 6. Okay, so we need the total possible outcomes that could occur. Well, there's 2 6-sided dice, so remember in the last video or the one before that. If there's 6 sides on the first dice, 6 sides on the second one, if we multiply that together, we end up with 36 different combinations that would work. So we know that 36 would be this bottom number. Now, if I start to think about all the sums that would not be 6, there's actually a lot of them, right? I could do, and I'm going to use the laser so I can erase it, but like 1 and 1, if I roll 2 1s, that sum, 1 plus 1 is 2, not 6. 1 and 2 would work, 1 and 3, 1 and 4, 2 and 1, 1 and 2. There's so many of them. So if we want to use the complement to help us, we could think about, okay, well, what is the probability that we get 6? Right? And then we'd know that the rest of them would not be 6. So if I think about it that way, well, 1 and 5, that would give me 6, but so would 5 and 1, so there's 2. 3 and 3 would give me 6, or 4 and 2, or 2 and 4, and those are the only possibilities that would give me 6. So that would be 1, 2, 3, 4, 5 of the outcomes, 5 out of 36 would be, which means that 31 out of 36 would not be 6. So sometimes it's easier to think about the complement to help us calculate a probability. On this next example, if we're given the probabilities, then we can just do the subtraction and use kind of that rule. So if the probability of A is given and we want to find the probability of not A, or the complement, then we would do the probability of not A would be equal to 1 minus 0.45, or in other words, 0.55. Would be what we're looking at. As a fraction, again, if the probability of A occurring is 1/5, then the probability of A not occurring is the other 4 out of 5 times, or in other words, 1 minus 1/5, which would be 4/5. Okay, so calculating complements. Lastly, let's talk about odds, and let's just talk about the difference between finding the odds of an event and the probability of an event. So the odds of an event is not the likelihood of it occurring. Instead, it's just a comparison of favorable outcomes to unfavorable. So the easiest way for me to think about this one is if you think about any of you that compete in some sort of event, let's say like sports, and you're winning games or losing games, it's like a win-loss record. If you've played 7 total games, then you won 5 of them and you lost 2 of them, then we generally write it like 5 wins, 2 losses. So your record, right, is how we say it, is 5 and 2. That's just a comparison, right, of wins to losses. Now, if I said, well, what's the probability, given that you can calculate without any other variables, the probability you win your next game, well, you've won 5 out of 7, so we could calculate that probability and figure out what that would be. But again, odds is just that comparison. And we can write odds in favor, where we do the number of favorable outcomes compared to the unfavorable. Or we can do the odds against, which is unfavorable to favorable. So it just depends which one goes first and second. And even though you can write it as a fraction as seen here, I would write it as a ratio just so that we can tell the odds are different than calculating our probabilities. So again, let's look at example 6 and just compare these two. So this says determine the probability. So again, we're doing likely of it occurring of spinning a 4. So we look at our spinner over here, and it looks like there's a 4 here and a 4 here. So 2 possible 4s, right? I'm going to put probability of spin of 4. 2 of them are 4s out of the total 12 slots there. So that would be 1/6, right? We would write that probability as 1/6, or if you want to write it as a decimal, 167. If we determine the odds of spinning a 4, now again, the odds is just a comparison. So if there are 2 4s on there, then there are 2 favorable outcomes, and the rest of them, the other 10, are unfavorable outcomes. So this is a 2 to 10, or in other words, we simplify it just like we would a fraction, and we would say the odds are 1 to 5. Okay. Example 7. So this says the probability of winning a balloon dart game is 0.2. So again, recognize that's probability. The odds of winning a ring toss game, so this one's odds, are 1 to 5. Which game gives you a better chance of winning? So better chance clues us in that we're comparing probabilities. So think about, it's already given that the probability of winning the dart game is 0.2. So we just need to figure out, well, what's the probability you win the ring toss game, and we can compare that. So if the odds are 1 to 5, right, that means there's 1 favorable outcome and there's 5 unfavorable. So 1 plus 5, 6 total, right, outcomes. So 1 divided by 6, or 1/6, let's write it as a decimal so that we can compare it, would be 167. So if you look at that, 0.2 is definitely bigger than 0.167. So it looks like that the dart game, right, you have a better chance of winning because 0.2 is greater than 0.167. So again, just using the probability and comparing that related to the odds. And again, the odds are a comparison of favorable outcomes. So when you're calculating the probability out of the odds, look for the total, and that goes on the bottom. And then the favorable outcomes would be your top number. Okay, as you work through the problems today, there's some on the worksheet, there's some in the textbook. Just make sure that we're reading the instructions, looking specifically what it's for, and I will finish